Hello, this is Chemistry, the Central Science, 11th edition, and we are in Chapter 3. And this is the end of the chapter questions, question number 45. Determine the empirical formulas of the compounds with the following compositions by mass. All right, this is hard. It's not hard because there's anything hard about it, but it's involved, meaning there's lots of steps that you could get lost at different places. So right now I have percent. Percents means out of 100 or per numbers out of a possible 100. So if I have 10.4%, then I have 10.4 grams out of 100 grams. So if you think of a 100 gram sample, 10% of 100 grams is 10.4 grams, okay, of carbon, 27.8 grams of sulfur, and 61.7 grams of chlorine. So all I did was assume 100, I can get any amount. I can take a spoon out of the jar of any amount. If I get exactly 100 grams, well then 10% of it just makes the math easy. Okay, otherwise I have an extra math step at the beginning to find out what 10% of whatever number it happens to be. If I pick well, then I can do it in my head. So I'm just going to assume a 100 gram sample. So 10.4 grams of carbon in the sample, 27.8 grams of sulfur, etc. Okay. Now, if you remember, in order to get a ratio, which is the formula, I'm not interested in weights because weights have to do with every element has a different mass. Every element has different numbers of protons and neutrons. So 20 grams of this and 20 grams of that isn't the same amount. Some things are big. So 20 grams of sugar and 20 grams of bowling balls is a different amount. Okay, it's the same weight, but it's a different number. Okay, so I want numbers, and so I need to turn grams into moles because mole is a number. It's a huge number, but it's still a number. So if it's a 1-to-2 ratio, then it's a 1 mole to 2 mole ratio. Okay, so if I can turn these grams into moles, and I do that through the periodic table. So I'm going to say here, I'm going to go to carbon on the periodic table. It's 12.01 grams per mole. Okay, sulfur, I go to the periodic table. Sulfur is 32.065 grams per mole. And chlorine is 35.453 grams per mole. All right. So all I do is divide. So I get my calculator. 10.4 divided by 12.01. And I'm now canceled grams and I'm in moles. So I now have 0.8659 moles of carbon. Okay, let's do the same thing with the sulfur. 27.8 divided by 32.065, and I have 0.8669 moles of sulfur. Let's do chlorine. 61.7 divided by 35.453 gives me 1.74 moles of chlorine. Okay. Now, I don't like these decimals because I want a ratio. I want whole numbers. I want 2 to 3 or 1 to 2 or 4 to 5. I don't want 0.8659 because we're not going to have 0.86 of a sulfur atom. We're going to have multiples of sulfur atoms. We're going to have 2 of them or 10 of them or 40 of them. We're never going to have 0.865 of them. But these numbers are related to each other. I can see right now that whatever carbon is, whatever the number under carbon, sulfur is exactly the same because 0.865 and 0.866 is essentially the same. They're just a millionth off, okay, or 10,000th off. It's just a little bit of rounding, no big deal. Those are going to be the same number. So I'm going to look for the smallest number and divide into each one of them. So let's just pick the first one, the 0.86, okay? So 0.8659 into itself is going to be 1, okay? 0.865 into itself is 1, and I'll have to fudge it just a tiny bit. Okay. What about into the 1.74? 1.74 divided by 0.8659, and I get 2.00, which is exactly 2. All right, do you see? Now I've got my subscripts. My first one was carbon, so it's going to be C1. My second one was sulfur. It's going to be S1. And my last one was chlorine. It is Cl2. Okay? That is an empirical formula. The empirical formula is the smallest ratio of the molecule. Now, I don't know exactly what this is, but it's going to be a multiple of it. It might be C2S2Cl4, or it might be C3S3Cl6. I have no idea, but it's some combination. So the empirical formula is the smallest ratio. Okay? All right, let's do this next one faster. Try as best you can to be doing this. Okay? So I'm going to start with 100 grams. So 21.7 grams of carbon, 9.6 grams of oxygen, and 68.7 grams of fluorine. I'm going to divide by 12.01 grams per mole. This is all from the periodic table, 15.9994 grams per mole. Fluorine, I have to look up, 18.998 grams per mole. Okay, now divide. Grams cancel. Grams cancel with grams, and you're end up with moles. All these now will be moles. So 21.7 divide by 12.01 equals, and I have 1.807 moles of carbon. Next one, 9.6 divided by 15.9994 gives me 0.6 moles of oxygen. Last one, 68.7 divided by 18.998 gives me 3.616 moles of fluorine. Okay. All right, I don't want 1.8 of this, and I don't want 0.6 of this. I want whole numbers. So I'm going to take the smallest of these numbers, which happens to be 0.6, and I want to put it into each one, divide into each one. So 0.6 into 0.6 is 1. Okay, so let's do the next one. 1.807 divided by 0.6 gives me 3. You see what's going to happen? That 3 is going to be the subscript. Now 3.616 divided by 0.6 gives me 6.02. So 3, 1, and 6. So the 3 is the carbon, so it's C3. The O is just C3O, and F is C3O F6. Okay, that's the empirical formula. Here's the last one. 32.79 grams of sodium, 13.02 grams of aluminum, and 54.19 grams of fluorine. I can steal fluorine because I just had it. So this is 18.998 grams per mole. Aluminum I have to look up. Aluminum is 26.98. 26.98 grams per mole. And sodium is 23 something. 22.989. 22.989 grams per mole. So divide those numbers. 32.79 divided by 22.989 gives me 1.426 moles of sodium. 13.02 divided by 26.98, 0.48 moles of aluminum. 54.19 divided by 18.9. What was it? 15.998. 2.852 moles of fluorine. So take the smallest one, that's the 0.48. 0.48 into itself is 1, so there'll be 1 aluminum. 1.426 divided by 0.48 is 2.97. Yeah, I'm going to fudge just a little bit. 2.97, that's 3. Okay, next one, 2.852 divided by 0.48. 5.94, close enough to 6. Okay, so the first one was sodium. So is Na3, Al1, F6. Okay, nice hard problem.